In this session we will be talking about velocity in 2 dimensions. Okay, so let's consider a coordinate system like this. So this is the horizontal axis, which is x-axis, and this is vertical axis, this is y, and let's say this is origin O. Okay, let's say I have a particle, some particle is there, let's say its position is here. So let's say the position coordinates of these particles are x1 y1, or let's say x0 y0. We will say x0 y0. The position coordinates are x0 and y0. So initially this particle is at this position. Okay, so I will draw a vector from this point O. Okay, so this let me draw a vector like this. Okay, so this is vector. Let's say this is r0 bar vector. Okay, what does it say? It says that the position of this particular particle is x0 y0. Okay, so this is r0 bar vector. So it says that it tells about the initial position of our particle. Okay, this is a vector r0 bar. And let's say after some time you find the particle at some other point. Let's say you find it here. Okay, so let's say this is the x and y position. Okay, let me call it x dash y dash. Okay, because x y we have already taken for denoting the axis x and y. So here x dash y dash is the final position of the particle. Now let's say the vector which is showing this position is r dash bar. Okay, so this is the position vector of this particular particle. Why position vector? Because it shows the position of that particle, right? So r dash bar is final position of the particle. Okay, so how did the particle go from r0 bar position to r dash bar position? So note here, I will be talking about the position not in terms of x0 y0. I will be calling the position vector of that particle. Okay, so this is r0 bar, that means the initial position, and r dash bar is final position. Now we have to find out what is velocity. Okay, so let's say, what is velocity? By the way, velocity we know is equal to displacement divided by time. Okay, so assume that it went to this, from this point r0 bar to r dash bar with a uniform velocity. So here the uniform velocity can be written as displacement by time. Okay, so velocity v bar, I have to use v bar here. Let me use v bar. Velocity v bar is equal to displacement vector divided by time. So what is the displacement vector? So the displacement vector is the vector that starts from the initial position to the final position. So this is the displacement vector, right? So what is this vector? How will you denote this vector? See, r0 bar plus this green vector is r dash bar, right? So that means this vector is r dash bar minus r0 bar. So this is the displacement vector. So I will write here r dash bar minus r0 bar is displacement vector. Okay, so this is the displacement vector. So the displacement vector is r dash bar minus r0 bar. Okay, the 0 is here, by the way, not here. Okay, so this is the displacement vector divided by time. Let's say the time is t. In the time t, this particle moved from r0 bar to r dash bar with a uniform velocity. Okay, because if the velocity is different at each point, then you will be considering average velocity. So if it was not the same at each point, then we would have considered average velocity. But since it is a same velocity at each point, I am taking directly v bar. So v bar is displacement by time. So now what is r dash bar? So you know that r dash bar can be written as x dash I cap plus y dash j cap. See properly over here. Here r dash bars coordinate are, that is the position coordinates of this particle, final position coordinates are x to x dash y dash. So similar, so here I can write its in a vector form like this, x dash I cap plus y dash j cap. And similarly for r0 bar I can write it like this, x I cap plus y j cap. So what is this? R dash bar minus r0 bar. It is x dash I cap plus y dash j cap minus x I cap plus y j cap. So what is this? X dash minus x I cap plus y dash minus y j cap. So this is our displacement, right? And divided by time. So the velocity v bar is equal to this, okay, divided by time. So this is our velocity expression. Now if I write the velocity vector in terms of components, vx I cap plus vy j cap, and if I compare these two equations, then what I will see? You can see that vx must be equal to x dash minus x by t. So vx is equal to x dash minus x by t, and vy will be equal to y dash minus y by t. Okay, so what is the meaning of this? The meaning of this is that the velocity in the direction of x is nothing but the displacement along x direction divided by time, and velocity vy is nothing but the displacement along y direction divided by the time. Okay, so velocity along x direction doesn't depend upon the displacement in y direction. Okay, and similarly the velocity in a y direction doesn't depend upon the displacement in x direction. They are independent of each other. So indeed you can see this two-dimensional motion as independent or as a combination of or separate independent motions along x direction and y direction. Okay, so superimposition of these two motions along x direction and along y direction will result in this particular motion. Okay, so this is the thing that I wanted to convey here. Okay, so remember that in two-dimensional motion the velocity along x direction doesn't depend upon y displacement in y direction and vice versa. Okay, so these two can be treated independent of each other.